Hello, good morning. Now I am going to give a talk about a research study which was a part of my PhD research project. Title of this study, Role of Organic Compounds in Soil pH Change. Background of this study. The influence of organic matter and its cycling on soil pH change is unclear because we have some contradictory reports. Some reports showed that addition of organic matter increased soil pH. Other study shows that decreased soil pH, and even some studies showed that there is no effect on change in soil pH after addition of organic matter. Why this happening? I think it's those study use different type of plant material as organic matter, and maybe their soil type was different or weather condition is different. I think composition of plant material is a major thing which can change in soil pH because plant material contain different individual organic compounds, and these organic compounds are different in their nature. Some organic compounds are acidic, some are basic, and some are neutral. These organic compounds also contain functional groups. I think these functional groups also have some impact on changing soil pH change. Aims of this study were to investigate the mechanism by which organic compounds alter soil pH and to examine the effect of organic compounds on biochemical processes and contribution of carbon and nitrogen dynamics to change in soil pH. Hypothesis: soil pH change after organic compound addition would be related to the contribution of chemical functional groups to biochemical processes. Experimental design. 7 organic compounds were selected based on type and number of functional group which commonly found in plant residues. In this aspect, 5 low molecular weight carboxylic acid, acetic, malic and citric, benzoic and ferulic acid were selected, and glucosamine hydrochloride were selected as a nitrogen compound. This glucosamine contains amine group, and glucose contain hydroxyl groups. These organic compounds were added 0.5 gram carbon per kilo soils. 2 soils were selected based on initial pH, podosol and tenosol. Podosol had the initial pH 4.5 and tenosol had the initial pH 6.2. Methodology: soils are incubated, pre-incubated at a bag for 10 days, and then these organic compounds are mixed as a stock solution in a bag, and then these soils are transferred to individual plastic core. This core contains 80% of fill capacity and 25 gram soil. This individual plastic core is placed in an incubation chamber. This chamber also contains a small container with water for reducing soil drying, and these chambers are incubated 25 degrees centigrade for 60 days. Sampling time 0, 1, 3, 7, 15, 30 and 60 days. The findings: this is the pH dynamics after addition of organic compound. This upper 3 is represent the podosol, and lower this 3 is represents tenosol. These A and D are the aliphatic carboxylic acid, the B and E are the benzoic and ferulic acid, C and F are glucosamine and glucose represents. Here you look, here original pH is 4.5, but after addition of organic acid, the acid instantly pH drop because of the dissociation of hydrogen ion from the carboxylic acid. After this, from this point, this recovery starts, and the pH recovery starts because of decomposition of organic ion in a the decarboxylation of organic anion which consume hydrogen ion. And similar things is happen with the tenosol, but the magnitude of pH drop is greater in tenosol than the podosol. Here one interesting thing is that pH recovery is much faster in tenosol than the podosol. For pH recovery, it's 60 days took for original pH, but here just 3 days it goes to the original pH, and after that at 7 and 15 days is the additional alkalinity I got after addition of malic and citric acid. Similar trend was also observed for benzoic and ferulic acid, but magnitude of pH drop is lower than those compounds. And you look here, after addition of glucosamine and glucose, no change in pH in immediate effect. No change in immediate effect after addition of glucosamine and glucose, but over time soil pH increase a bit with addition of glucose. But in the tenosol, but in the podosol is slightly decreased the soil pH. But after addition of glucosamine hydrochloride, soil pH decrease over time in the tenosol, but in the podosol there is slightly decrease. Here cumulative respiration also showed that decomposition is lower in the podosol than the tenosol. Here you look, after addition of organic compound, cumulative respiration was increased than control. But addition of malic, citric and glucose got the higher respiration than other compound. Here another important thing is that you look, we added 5 gram carbon per kilo soil, but we got the cumulative respiration after 60 days is lower than the added carbon in the podosol, but higher than the added carbon in tenosol with malic acid, citric acid, benzoic acid and glucose addition. Now the ammonium, that means nitrogen dynamics. You look, after addition of acetic acid in tenosol, ammonium concentration is slightly increased, and with the glucose addition, no change in the ammonium concentration, but after addition of glucosamine, ammonium concentration was increased over time from 3 days. It significantly increased, but in the tenosol, you look, ammonium concentration was increased from 3 days to 15 days and reached a peak, and after that soil pH was decreased. And now nitrate dynamics. You look, addition of organic compound has no effect on change in nitrate concentration in low initial pH soil, even nitrogen compound added to the soil. But in the tenosol, there is you can see a change in the nitrate concentration. Addition of organic acid from 1 day, they slightly decrease nitrate concentration, and same thing is happen also. You look with the addition of glucose addition from 0 day to 1 day, nitrate concentration decrease due to the nitrate embolization of microorganism, and then it continues throughout the incubation period. But you look, nitrate concentration was increased up to 15 days is a slower rate. When ammonium concentration also goes up, but after you look in the previous slide, in that point ammonium concentration goes to the peak, and then ammonium undergoes the nitrification process, and then nitrate concentration increased. Conclusion: acidic functional groups initially decrease pH due to dissociation of hydrogen ion, followed by increase in pH due to decomposition of organic anion. Neutral functional group had no immediate effect on soil pH, with glucose change in soil pH is very small compared to the other compound. Amine group had no immediate effect on soil pH, and also it had no effect on the low initial pH soil. But in the higher initial pH soil, pH can subsequently decrease when ammonia is good nitrification. Malic, citric and folic acid to the tenosol stimulated alkalinity release, resulting in a priming effect, probably due to the stimulated microbial nitrate uptake, ammonification and decomposition of indigenous soil organic matter. We got the higher alkalinity release and CO2 priming. For that reason, further studies using carbon isotopes are warranted to determine the exact contribution of each carbon pool in soil to the generation of additional alkalinity and CO2 priming. Thank you, everyone. Bye.